Have you ever just stopped and really listened to a toddler and wondered, how on earth did you do that? I mean, how did you go from a tiny crying baby to this little person with actual opinions and jokes and stories? It's been called the most extraordinary story in science, a quiet miracle that happens in basically every home. Okay, let's dive into what is really an intellectual detective story.
This right here, this is the central mystery we're going to try and solve today. How does this incredible universal human feat actually happen? What's the secret sauce that lets a baby, with absolutely no instruction manual, unlock the super intricate code of their native language? So let's put on our detective hats and start following the clues. Where do we even begin?
Well, our first major clue is this. The path they take is incredibly predictable. It doesn't matter if you're learning Japanese, Swahili, or English. All children follow what researchers call developmental sequences. And these aren't just random steps. They're a clear, stage-by-stage journey that really suggests something fundamental is at play here.
Let's just take a simple example, like saying no. A kid understands the idea of no pretty early on, right? But look at how they learn to say it grammatically. First, they just stick no on the front, no bicycle. Then don't shows up, but it's not quite right yet. Slowly, they master the more complex forms until they get it. And what's amazing is this same step-by-step process happens in languages all over the world. It's like a universal roadmap.
And you know, it gets even more complicated with questions. Check out this path. It's incredibly logical when you see it laid out. Kids don't just jump to asking complex questions. They build up to them, one piece at a time. They might start with a single word and a rising tone, like doggy? Then they learn to put a question word at the front, but without changing the rest of the sentence, like you see there in stage 3. Why you don't have one. It actually takes 6 distinct stages to master the whole shebang.
And get this, while all this complex grammar is being built, their vocabulary is just exploding. We are talking several new words every single day. It's just incredible. By the time they start school, a kid has been swimming in their language for about 20,000 hours. The sheer speed and scale of all this is just astounding. So how in the world do we explain?
Okay, this brings us to our first theory. And if you were a detective on this case, this is totally the suspect you'd investigate first. It just seems so obvious, so straightforward. But as we're about to see, the simplest answer isn't always the right one.
So, the behaviorist perspective basically argues that language is no different from any other skill, like learning to ride a bike or tie your shoes. Children hear words, they imitate them, they practice, and they get positive feedback, a smile from mom, or getting the cookie they asked for. It's just a simple loop. Imitate, practice, reward.
And there's some good evidence for this. Right here, we have 2-year-old Peter. His mom says, yes, the dump truck fell down, and what does he do? He immediately repeats the key parts of it. Case closed, right? He's just imitating what he hears. Simple.
But wait, not so fast. Here's the plot twist. If language is just imitation, why do kids constantly say things that no adult around them would ever say? This is where that simple behaviorist theory starts to run into some serious trouble. And this, right here, this is the smoking gun. Think about it. No adult says putted. This child isn't just mimicking. This isn't a little tape recorder playing back what it heard. This is a tiny scientist, actively figuring out the rules of their language and then testing them out. It's a totally active, creative process.
So this creative mistake, this little flaw in the first theory, it led to a radically different idea. What if the answer isn't really in the environment at all? What if it's actually inside of us from the moment we're born?
This is the Innatist perspective, and it's most famously connected to Noam Chomsky. The big idea here is that the human brain comes pre-wired with what he called a universal grammar. Think of it like a blueprint for language. It's not the specific rules for English or Spanish, but the underlying architecture for all languages. The child's job is just to listen and figure out which switches to flip for their language. Does my language put the verb before the subject? Flip that switch. The blueprint is universal, but the final house is unique.
And the evidence for this is pretty compelling. First, pretty much all children succeed at learning language, no matter what their circumstances are. Second, there's this logical problem. The language kids hear is often messy, it's incomplete, it's full of ums and ahs, and yet out of all that messy input, they build a perfect, complex system. How? Well, they must somehow know more than they've actually been taught. And finally, there seems to be this critical window in childhood where learning a language is just way easier.
But maybe it's not a simple case of nature versus nurture. Our third clue suggests that the solution is more like a collaboration, a social puzzle, where the child and their world have to work together.
So the interactionist perspective is kind of the great mediator here. It agrees that, yeah, children have these innate abilities, but argues that language only truly emerges from the dynamic interplay between those abilities and their social world. It's not just what's inside the brain, but how that brain connects with other people.
Now, within this view, you have two giants, Piaget and Vygotsky. Think about it this way. For Piaget, a child plays with blocks, understands that one is bigger, and then learns the word for it. The understanding comes first. But for Vygotsky, it's the other way around. A parent says, hey, can you give me the bigger block? And it's through that conversation that the child learns both the word and the concept at the same time. The conversation itself creates the thought.
Okay, so we've gathered all the clues. We've looked at imitation, an innate blueprint, and social interaction. So what's the final word? Who done it in our detective story?
So let's look at what our suspects got right. The behaviorists, they were absolutely right that kids are amazing pattern finders. The Innatists, they were spot on that children are creative rule makers, not just little parrots. And the Interactionists, they totally nailed it by showing that social connection is the spark that really lights the whole fire. Each theory holds a crucial piece of the puzzle.
And that's the real takeaway here. The mystery isn't solved by a single suspect. Language acquisition isn't just one thing. It's a perfect storm. It's the convergence of a brain that's built for language, a world that's full of patterns to learn from, and the very human connection that makes it all meaningful in the first place.
So here it is, the complete picture. You need an innately prepared brain, just like the innatist argued. That brain then has to detect patterns from the world around it, exactly as the behaviorist described, and all of this is sparked and guided by the power of social connection, which is the heart of the interactionist view. It's biology, cognition, and environment all working together in perfect harmony.
And that synthesis, that complete picture, leaves us with one final and really important question. Knowing that this amazing feat depends on all three of these things, what does that tell us about our role? How can we create the best possible environment to support the next generation of little talkers as they set out on this incredible, magical journey?